All right, let's quickly talk about the third example. And the third example says that we should show that if A and B are two sides or are two vectors, then we should show that A plus B should be equal to B plus A. Sorry about that. So when we add A and B together, it should be the same thing as B and A. Now, how do we go about this? We go about this by drawing a parallelogram. So the adjacent sides of a parallelogram. So the first side, let's call it A, while the second side, let's call it B. So these are the two adjacent sides of a parallelogram. So if B goes like this, while A goes like this, so I can use these two adjacent sides to draw a parallelogram. Now let me draw a parallelogram with this. So which is gonna be also like this and also like this. So let's give the parallelogram A, B, C, D. Now we have to get out that A plus B is the same thing as B plus A. So from this diagram, it's easy to see that if the first side here is A, then the opposite side that is parallel to side A is also A, because one of the properties of parallelogram is that opposite sides are equal and parallel. Likewise, if this AB is B, it means this C will also be what? Will also be B, because the opposite sides of a parallelogram are equal. So let me join A to C. So I'll be having a direction like this. So our A plus B, as stated, we have A plus B, or we can say A plus B. So our A plus B is the same thing as saying AC is equal to B plus A. So if I want to move from A to C using this side of the triangle, so we have two sides of triangle now forming the parallelogram. So using this first side of the triangle, A to C, same thing as moving from A to B, then from B to C. Okay, let me even write it like that. Let me write it like that first and foremost, that we have something clearer. So using the first side of the triangle there, AC is same thing as moving from A to B, then B to C. And we already know that A to B is B and B to C is A. So AC is B plus A. So I can write inside here A to C as B plus A. That's for the triangle there. Then likewise, let's quickly move and pick the other triangle, which is this triangle here. So we have A to C is also the same thing as me moving from A to D, then D to C. Also, AD is the same thing as me moving from, AC, A to C, same thing as me moving from A to D, then D to C. And our AD is A, while DC is B. So therefore, AC is also the same thing as A plus B. So using the second triangle, I can write AC here as A plus B. And as you can see, the both of them are AC. So therefore, I can say A plus B equal to B plus A. And the both of them are AC. And both of them are AC. Now, this is called the commutative law of vector addition. Let me write it. It's called the commutative law of vector addition. That's what it is called, the commutative law of vector addition. For most of us that don't know what commutative property is, when an arithmetic operation is commutative, it means it doesn't matter which of our numbers comes first, the answers still remain the same. Let's take, for instance, addition as an arithmetic operation is commutative. So if I have 2 plus 5, it's the same thing as 5 plus 2. 5 plus 2. Both of them will give me 7. And that is what they mean by commutative. So addition in this case, as an arithmetic operation, is commutative, in that it does not matter which one you pick first, the answer still remains the same. So if I pick 2 first before adding 5, the same thing as me picking 5 first before adding 2. And likewise, multiplication as an arithmetic operation is also commutative. So if I say 2 times 5, the same thing as me saying 5 times 2. This shows that multiplication is commutative. It doesn't matter which one comes first or which one comes last, the result remains the same. And that is what commutative property is all about. So having known that addition and multiplication are commutative, you need to also know that subtraction and division are not commutative. How? Because if I have 5 minus 2, it is never going to be the same thing as 2 minus 5. Because 5 minus 2 is going to give me 3. But 2 minus 5 is going to give me negative 3. So 3 and negative 3, they are not the same in any way. And likewise division, if I have 5 divided by 2, it's never going to be the same thing as 2 divided by 5. 5 divided by 2 is 2.5. 2 divided by 5 is 0.4. As you can see, the answers are not the same. So with this, we are able to establish how that addition and multiplication, they are commutative, while subtraction and division are not commutative. So let's digest this before we move to the next example. All right, example 4. Example 4 says P, Q, R, and S are vertices of a quadrilateral such that A and B are the midpoint of the side QR and PS respectively. So the question is that we should show that AB is equal to half of QP plus RS. Now, in order to answer this question, we need to sketch the quadrilateral with vertices PQRS as we have been told. Now, let's quickly sketch the quadrilateral. So, since the quadrilateral, let me just sketch Let me just do something like this. So I have P, then I have Q, then I have R, then I have S. Now, A and B are midpoint of the side QR and PS. Where's QR? Okay, this is QR here. So we have point A here, midpoint. Don't forget. Then the side PS. This is the side PS here. Point B here. So let me join A and B together. Now joining A and B together automatically shows that we have divided the quadrilateral into two. That is one, that's PQAB, then two, which is BARS. So we have divided quadrilaterals into two other quadrilaterals. So the addition of these two quadrilaterals gives me the whole quadrilateral that was given, which is PQRS. Now from here, if you want to show how that AB, because that's the question, is equal to half into bracket QP plus RS. So we need to get two values for AB. The first value you can get for AB is using the first quadrilateral, which is quadrilateral 1. Then also you can get another value for AB using quadrilateral 2. So using quadrilateral 1, it's easy to see that AB is the same thing as moving from Q to A, or rather from A to Q, like this, then from Q to P, then from P to B. So moving from A to B can also be done using moving from A to Q, then from Q to P, then from P to B. So AB is AQ plus QP, then plus PB, plus PB, plus PB. So AB is AQ plus QP plus BPQ. Plus BP. So that's the first way we can get AB. Also, using quadrilateral 2, we can also get AB by moving from A to R, then R to S, then S back to B. Also, AB can also be gotten when we move from A to R as AR plus R to S, RS, which is like this, then plus S to B, SB, which is like this. And as you can see from the arrow that I already drew, since A is the midpoint between Q and R, it means AQ must be the same thing as AR because A is in the middle. But the only difference between them is different direction. AQ and AR, they are in the opposite direction, but the values, they are the same. So let us represent AQ as A. It means AR will be minus A because the values are the same, but the directions are opposite. So the same thing is applicable to PB and BS. Same thing is applicable to PB and BS because B is the midpoint between P and S. So if we represent PB as B, then BS will automatically be minus B. Why? Because BS, rather SB is going to be minus B. because that's the direction. S to B. You can look at the direction of my arrow. So SB and PB. So if PB is B, then SB is definitely going to be negative B. So let me just represent my QP, because that's the direction of the arrow, as, let me use C. Then let me represent RS, which is the direction of the arrow, as D, so that we can be using A, B, C, D, negative A, negative B, into all this. So we have two values for AB. The first value is using the first quadrilateral, which is AQ plus QP plus PB. Then also the second value of AB is AR plus RS plus SB. Now let's quickly add these two together. So that means 2AB is the same thing as having the first one here and the second one here. So I want to add the both of them together. So same thing as saying AQ plus AP, QP rather, QP, and plus PB. Then also plus the second one, AR, then plus RS, then plus SB. So this is the value of 2AB. And as we already know, how that AQ is A, while AR is minus A. So let us represent all these sides with the representation that I've given. So we have equal to AQ is A plus QP is C plus BP, PB is B, so plus B, then plus AR, AR is minus A, so minus A, then plus RS, RS is D, then plus SB, SB is minus B, so minus B. So we have all this. Now when we put all this together, we have how that A and minus A, we cancel each other out. And we have how that B and minus B, we also cancel each other out. So thus, we are going to be having from here, we are having C, then plus D. C plus D. Why? Because this has cancelled out this, and likewise this has cancelled out this. So we are left with C, then plus D. So 2AB, let me write it here. 2AB is C plus D. Now let us now put back what C and what D are in terms of from one point to another point. So we know that C is the same thing as QP. So since QP is the same thing as C, and also D is the same thing as RS. Also, RS is D. So let us now change back C and D as QP and as RS. Hence, 2AB, as we have here, is going to be C plus D, which we already know. And that's what? QP plus RS. So if 2AB is QP plus RS. Then we can divide both sides by 2. Then AB is definitely going to be what? QP plus RS divided by 2. And that's AB equal to half of QP plus RS, which has been established. And see how simple all these things are. I believe you should be able to solve as many problems as possible. But do not forget, subscribe and like my channel. Subscribe to my channel, like my channel if you have learned something in this class.